Hi, good evening. Okay, it looks like we have enough feedback that you can all see it. Okay, so Kanban, an alternative path to agility. This is the same talk that I'm giving as the keynote speech at the Agile Days Russia here in Moscow on Friday. And because this evening we have some extra time, I have a few extra slides that I won't be using at the conference. So let's get started. First of all, a slide to remind people what the real meaning of Agile is, the whole concept of Agile software development. For many people who came to it recently, that they perhaps don't fully understand some of the origins and motivations for it, and as a result of commercialization of the Agile movement, the true meaning has been lost and people can't think about it rationally. It's become quite religious and dogmatic in some parts of the world. So what Agile methods seek to achieve, I'm not going to bore you with the slide on the Agile Manifesto. More really, what does that stuff mean? Well, probably the first key idea is that Agile methods expect you to make progress with imperfect information, and that's a faster and cheaper choice than delaying trying to build the most perfect requirements with the most accurate analysis. It would be better to make progress with imperfect information and rework the code and the product that we're developing and course correct as new information arrives. The belief is that that's better risk management. So it's a core concept in Agile development. There will be some circumstances where that's not an appropriate assumption, but it's a core assumption for the Agile movement. The next one is enable a high trust culture in your organization. I have no idea what the message is that's being prompted to me. I don't understand. Please add a higher frequency. If you want me to do that, you need to send someone into the room to show me what to do. So getting back to the presentation, enable a high trust culture. The idea of a trust dividend is that it eliminates bureaucracy and it encourages collaborative working in your workplace, collaboration, and the use of tacit knowledge rather than trying to document things physically. The understanding that we actually share information or store information in the heads of other people, and that we don't need to remember everything, because as long as we have our colleagues around, between all of us as a group, we have this collective knowledge. And if we tried to capture that knowledge and store it, that would be time consuming, and it would have quite a significant deterioration ratio. We're not particularly good at writing things down which are in our heads, and we're also not particularly good at reading material that others have written and fully understanding them. It's much easier for us to do face-to-face communication, talk with each other, tell stories about things. The quality of understanding is so much better. Of course, to make that work, you need to have the confidence that you can keep a team of people together and that knowledge will not walk out the door when someone decides to leave your company and go work somewhere else. The next one is treat work in progress as if it were a liability rather than an asset. understand the idea that knowledge work is perishable, and therefore you should focus on finishing things quickly before they go stale. So in order to do that, we might try to use very short time windows for starting and finishing work, and we might focus on very small batch sizes and limiting the amount of work that we have in progress at any given time. This enables us to transfer ideas into working product as quickly as possible, hopefully delivering it before the idea is irrelevant or that our understanding of the idea has changed. The next one is create feedback loops and enable a capability to adapt. Now, what I'm calling here first generation Agile methods, these are mostly from the 1990s, and the methods that various people brought together at the formation of the Agile movement in 2001, their focus was on adapting to changing requirements or project scope, and the feedback mechanisms and the increments or iterations within the methods were really designed to allow changes to the requirements or new information arrival to happen during the project, and therefore to provide a way of deferring commitment on the total scope for a project until later, that you'd only start a small amount and commit to a small amount of the requirements on the first time-boxed iteration, and then move forward gradually committing to one small batch after another. If there is a concept of a second generation Agile method, and we might position Kanban as one of those, then it's that this adaptive capability goes beyond just adapting to changing requirements, but it's more an organizational capability that your whole organization and the process you're using, the way you're responding to customer demand, that can adapt. Not just that you are adaptive to changing requirements, that the organization is adaptive to a changing external environment, changing market conditions. Lastly, the Agile movement has this craftsmanship work ethic that we need to encourage a high standard of professionalism in software development, that we should focus on high quality, well-engineered code that is itself easily adapted or refactored, as the people in the early Agile movement prefer this term. And therefore, as new information arrives, in theory, our code should require little rework due to errors, and it should require an insignificant amount of re-architecting as new information arrives if we've built code that's highly cohesive and loosely coupled or well factored. So if that's the background for the Agile movement, why is Kanban an alternative path to agility? Well, I started down this path to the Kanban method I'm seeing a message saying there's no sound. Can people hear me? Okay, thank you. It seems most people can hear me. So I started down this path to doing Kanban primarily because people working for me or working in the companies where I worked in 2000, 2001, 2002, they were largely resisting the adoption of Agile software development methods. We could get one department to do it. That was fairly easy. But when we were asked to scale that to a business unit, perhaps 350 people, many of the other departments within the same business unit, often on the same floor of the same building, those people started resisting. And I came to the conclusion that it wasn't necessarily one Agile method or another that was right or wrong, or that there was any one particular way of building software that was better. I came to realize that people resist the idea of change that affects them personally, and it didn't really matter what you were changing to, they would still resist. So I started to look for a different way of improving the agility of high technology businesses, a way that would allow us to make changes in an incremental and evolutionary fashion, and that we would abandon the idea of taking a defined, prescriptive Agile software development method and trying to install it into an organization. So Kanban became the method where you start with what you do now and you evolve, and the objective is to improve the agility of your business. It's the antithesis of the religious belief that Agile software development is a better way to build software. It's the pragmatic approach of, I don't care how you build the software, let's make sure that our business is operating with greater agility, because ultimately that will lead to better results for the business, better results for the employees as a consequence of the business doing better. So the Kanban method is a management and cultural approach to improvement. It's a way of viewing creative knowledge work as a set of services, and it encourages a management focus on the demand that you receive. That could be, demand for software. It could be demand for some other knowledge work or creative service like user interface design, database administration, various IT ops or engineering services. And that we should understand the business risks that are associated with these requests, and also understand our capability to service the requests and supply against the demand. And if we can understand all of those things, the demand, the business risks, and our capability, then we can try to bring those things into better balance, and the result should be better service delivery. So it's a really critical point, and I usually find that I have to repeat this many times with people who've been exposed to Agile software development or software engineering methodologies in general. Kanban is not a project management or software development lifecycle process, and nor does it encourage a process-centric approach to improvement. Kanban is not about installing a new process in your organization. It's about installing a mechanism that will allow your current processes to evolve, and the business agility that those processes exhibit will improve. So this diagram is designed to highlight the 20th century approach to industrial engineering and improvement in physical industries. That traditionally in Western society, there's the concept of capitalists. Capitalists had the money to own factories, plant, equipment, and they would employ workers to work in their factories. And very early on in the Industrial Revolution, it was very obvious that the capitalists weren't necessarily the best people to tell the workers what to do. So they started employing professional managers to operate on their behalf, to instruct workers what to do. And that worked fairly well through the 18th and 19th centuries. But by the early 20th century, it was clear that the scale that industry had achieved by that time required some additional expertise. And initially, those people were called time and motion men. And more recently, the professional title is industrial engineer. And they're essentially process coaches. They are people who understand the way of doing some work, and they design or define a process and then the workers are instructed to follow that process, to follow a particular way of working. And this concept has worked fairly well in manufacturing industry since the 1920s. I would suggest that it's really not applicable in 21st century creative knowledge work. The reason is that there is really very little separation between workers and managers, in the sense that with creative knowledge work, all workers make decisions, and those decisions affect the product or the service delivery, or the service being provided, or the delivery of that service. So in modern industries where people think for a living, the workers make decisions that affect the bottom line performance of the business. And this is not true in traditional manufacturing, traditional industrial engineering. It's the industrial engineers defining the process and the managers defining the system of management for the factory, which essentially affect the bottom line performance. Workers are generally not empowered to make a lot of decisions, or certainly not decisions that affect the performance of the business. They're instructed to follow the process largely without thinking. So the old model's really not applicable, because in our modern world, managers and workers are essentially the same thing. The only difference is at different levels of pay grade, they have different authority to make different types of decisions. But every single person in a knowledge work organization can make decisions that affect the performance of the business. Therefore, we need to stop thinking of managers and workers as two different classes of people. The people working on a software development product are making managerial decisions about that product every single day. Every time they type in a line of code, they've made some decision that will affect the performance of the business in the longer term. So we need a whole new model. The industrial engineering model is broken. So more specifically, the Kanban method is about visualizing invisible work and using virtual signal card systems to allow everyone involved to engage with this invisible creative knowledge work in a way that you would engage with a physical system. Managers or people with management authority in physical environments, they often make much better management decisions than we see in knowledge work industries. Even though they often have a lower level of education, they're actually much better managers. And I believe fundamentally that's because they can see what's going on and they can apply a lot more of what we tend to call common sense, that they're using a lot more of their sensory perception, their vision, their hearing, their feelings about things, not just some logical assessment of invisible work, perhaps captured with some metrics. So we want to be able to visualize the invisible and limit the work in progress with virtual signal cards, and we'll see how that works. And the result of this is that it will provoke an adaptive capability in your organization. I'll explain how that works. So the idea is that you take your current process, regardless of what it is, and without any religious bias about whether it's good or bad. You don't judge it. And you say, okay, whatever we do now is what we do. We're going to start with that, and we're going to Kanbanize it in order to catalyze our process to change and our service delivery to improve. And what we're looking for is that each of these service delivery workflows will become fitter for purpose. And as a result, both customer and employee satisfaction will improve. If you research Kanban, you will find a confusing amount of information. primarily the Kanban we're talking about here is inspired by the use of Kanban systems at Toyota. And when the Japanese are using the word Kanban, it can have two different meanings in Japanese. And they clarify these meanings through the use of their different alphabets, their kanji alphabet, which is the Chinese characters. And when they use that way of writing the word Kanban, it means that sign or visual board. So we're talking about anything from a billboard to the sign outside of a shop. And if they write it in their own alphabet, the hiragana, then it means signal cards. And the possession of a Kanban is something that indicates that you have permission to do something. So Toyota used these signal cards, these Kanban written in hiragana, to signal the supply of inventory within their factories. And that's what largely inspired what we're doing here. But I've come to realize that for a large number of people, Kanban means visual board or signboard. And they often interpret that to be the physical board on the wall with sticky notes on it, particularly in the Chinese market where the word Kanban only has one meaning, and it's this large visual board meaning. So I've come to realize that we can embrace both meanings of the word Kanban with the method that we're using. There are 6 practices you need to install in your organization to make this method of management work properly. There is visualizing the invisible work with a Kanban board, limiting the work in progress with Kanban signal cards, managing the flow, making policies explicit, implementing feedback loops. And then with all of those in place, looking to make improvements through collaborative activities and evolving your workflows and your service delivery experimentally, and that shouldn't be a random thing, that you should have some understanding of the dynamics of your process and how to make changes. Therefore, we use models to understand the situation, and we apply the changes systematically, and we observe whether there are improvements or not in a scientific way. And as we have a well-educated workforce, there's no reason why you can't do this. Software developers are scientifically educated and expected to apply that scientific education while making the products that they're being employed for. So why wouldn't you take that same scientific education and teach people how to understand workplace dynamics and workflow and service delivery mechanisms, and allow them to apply the same level of rigor to their way of working as they do to developing their product? So what's a Kanban system? This is an example of one that's in daily use in Japan. The plastic card in the upper left that says admission ticket, that is a Kanban. It is a signal card that signals permission for the people down in the bottom right to enter the park that's shown in the picture, and this is the Imperial Palace Gardens in central Tokyo. There are only 2 ways into this park because it's built inside the walls of the old medieval city of Edo. And the park's adjacent and surrounding the Imperial Palace where the Emperor of Japan lives. When you enter the park through one of the 2 entrances, you'll be given one of these admission tickets, and it says, please return this ticket at the exit. So you carry the ticket around in your pocket, and when you're leaving by either exit, doesn't need to be the same one you entered by, you return the ticket to the lady in the kiosk with the white gloved hand. These are not traditional admission tickets. They're Kanban in circulation, and what they're doing is limiting the number of people inside the park. And if all the Kanban are used, if they're all in circulation, then they prevent people from entering. They make them queue up outside until people who are leaving return their Kanban, and then those cards are recirculated to the ones who are queuing to come in. So in that very simple application, they're using Kanban to control the experience inside the park and to prevent too much wear and tear of the grass and the other plants and trees and bushes inside the park. They want to keep the experience of being in the park to be special, and they do that by limiting the number of people using a Kanban system. It's this same principle that's used in Toyota factories to ensure that they never have too much inventory of components at any one place at any given time. And that's known as a just-in-time manufacturing system. It has real benefits in manufacturing. The benefits are primarily that they limit the working capital that they expose in order for the factory to run, and they also limit the waste by avoiding loss through perishable inventory or overstocking of particular components that they turn out not to be needed. So the advantage of a Kanban system in manufacturing is the speed of manufacture, a reduction in the working capital, and generally an improvement in quality, a reduction in waste. It's not really intuitive that you would apply such a system to knowledge work, but many of the same benefits apply in our world. So how do we use a virtual Kanban system, and why is it virtual? Well, here's an example of a Kanban system, and generically these are known as pool systems. And this example process here is based on a real-world example. But remember, the method is that you start with what you do now and you visualize it. So you should never copy any of my examples. When you develop a Kanban system for yourself, you must base it on your own existing process. Now we see the Kanban at the top here, the numbers at the top of the columns indicate our capacity for the tickets on the board, and these tickets might represent user stories or change requests or bugs or use cases or whatever the particular work request might be in your work area. Let's imagine these are user stories. So we have a space here in test ready for 5. We only have 1, so we have some capacity. This enables us to pull an item from development done, and it will move into test ready. Our limit in development is 3, and we currently only have 2. This enables us to start something else, so we can pull that into development. And in our development ready input buffer, we have 5, and currently only 1. So we can select 4 more from our backlog of ideas, and we can pull these onto our board. This is the basic principle of how it works. We're limiting work in the system, and we're only starting work when there's a capacity to do so, which is indicated by the virtual Kanban at the top of the board. So this next slide just highlights this, that the Kanban are at the top and they're virtual. It is possible to implement physical Kanban. And this next slide shows you an example of that. You'll notice that this is in fact the same workflow, the same process as we had on the other screen. We no longer have numbers at the top of the columns. Instead, what we have are magnets on our whiteboard here. And each one of these magnets is a Kanban. And we can use color of the magnet to indicate different things. A white magnet might indicate in progress, and a white magnet without a ticket is therefore a Kanban pull signal that we can start something new. The green magnet indicates that something is completed and ready to be pulled to the next stage. And we're using red magnets to note that something's blocked because of an issue. and a blue magnet to indicate something's blocked because of a defect. We're also using a mechanism where there's a line at the bottom of some of the columns to provide a physical space to indicate done, and we would move the tickets down below that line when they're ready to be pulled to the next stage in the process. So this board and the previous one are actually equivalent visualizations, but now we have a physical token for the Kanban. Colors used to denote the state of the ticket, and perhaps we use a physical movement also to indicate done as a way of additionally emphasizing what's waiting. We may also override the Kanban limit when something is blocked with an issue, and you see in our testing column here we introduced a fourth Kanban, which is the I ticket at the bottom there. And what we might read into this picture is that whoever was working testing ticket A has been asked to stop what they're doing and test ticket I because it's more urgent, it's a higher priority. So they've marked ticket A as blocked while they're working on the I ticket. The next critical idea here is that if you've limited the work in progress, this means that the other work is not yet committed. So when we pull something onto the Kanban board, our input buffer here represents the point of commitment. And what we mean by commitment is that our business stakeholders have said, we definitely want to do this. We are sure that we want to take delivery of this particular item. And that's their commitment. We're sure that we want it. On the other side, we are promising, from a service delivery perspective, that we'll definitely do it for you and deliver it back to you. So we're committing to getting started. They're committing that they definitely want to take delivery. Therefore, once we start something, we would wish to avoid aborting it after commitment. If we start something and have to throw it away, that's obviously wasted energy, and we would have been better to choose something else, which would make it the whole way through our system and be delivered to the customer. Lastly, the upstream ideas remain optional. By definition, if they're not committed until the commitment point, they are therefore optional. And optional work should remain unprioritized. That there's a tremendous amount of energy wasted, particularly in software development, prioritizing work that may never actually get done, prioritizing it and reprioritizing it and reprioritizing it. A lot of time and energy spent on that, often by people who are actually working on the downstream committed work. And getting involved in prioritization is time wasting for them, often disruptive. And it's ultimately a wasteful activity because priorities are always changing. The discard rate of these upstream ideas is often very high. Many companies I meet are not measuring this, and if they did start to measure it, they may be surprised. Understanding the discard rate of this upstream work is a good way of encouraging customers to recognize that deferred commitment is a good idea. So the idea here is that if a ticket is rejected before we started it, we consider that discarded. It's an option that we've thrown away. And discard rates are often very high. The first ever Kanban system we implemented in Microsoft's IT department had a 48% discard rate. Discarding is actually a natural thing that we create options because we're uncertain about the future, that we always need to have more ideas than we believe we can implement simply because we're not quite sure exactly what we want yet. A zero discard rate would imply that there's no uncertainty about the future, and this is almost never happening in the software development world. There is always uncertainty about the future. The discard rate will always be greater than 0. This 50% number is commonly observed. It's remarkable the number of companies that I've visited or met, or people that I've met at conferences over the last 4 or 5 years. And if asked to make a rough guess of how much work they throw away, the number 50% is often reported. So if 50% of ideas submitted by the customer are rejected before we start them, it makes sense that we shouldn't commit on work until later. We can, of course, apply Kanban upstream, that we can expand our Kanban system to the left. And now this picture shows the commitment point in the middle, and the upstream activity is the exploration of the ideas, the development of a business case, the requirement analysis, the approval of the requirements to be ready for engineering. And you'll see here that therefore, with the commitment point in the middle, the committed work is to the right-hand side, and the work to the left-hand side is optional. You'll notice that the Kanban have minimum and maximum limits. The idea of the minimum limit is often referred to as a reorder point. It's the concept that we always want to have a minimum number of options to choose from. So if you look from the commitment column in the middle, the limit is 4. And if that column was empty, we would need to choose 4 things from the column immediately to the left, ready for engineering. Therefore, we want a minimum of 4 tickets to be in that column at any time, so we always have enough to replenish our committed buffer. But we might want to have some choices, some options. Therefore, perhaps as many as 12 would give us enough choice to make good business decisions on what we should start next. So we want between 4 and 12 items in ready for engineering at any given time. If we need to have 12 in ready for engineering, then really we should have a minimum of 12 in our requirement analysis activity, and perhaps a maximum of 24 will be sufficient to ensure that we can replenish our ready for engineering buffer with adequate choices. And then to the left of that, business case development, 24 to 48. Again, the idea that if we need a maximum of 24 in requirement analysis, we should have a minimum of 24 in business case development in order to give us choices. Therefore, we get the opportunity to reject items at any stage. We can reject them immediately as bad ideas, or we can reject them after we develop the business case or after we develop requirements. And what we see here is that the cost of acquiring our options, the choices we have for committed work, that cost increases the further to the right the ticket moves before we decide to reject it or not. Now, for many of you listening here at Luxoft, you realize this upstream activity probably belongs at your client. And that's, I think, a very valuable observation, that Kanban shouldn't be limited just to internal to Luxoft. It should be something that you should be looking to partner with your clients on and help them manage their business better, so that they're making better use of your resources, that they're asking you for things that they value more, and that your time is being better spent for them. They will then realize more value for the money that they're spending with the company. Next thing for us to care about with Kanban is the replenishment frequency. How often should we replenish our commitment buffer? In this example, the development ready. And there are some factors to be considered when we consider this replenishment frequency. Holding a replenishment meeting where we're asking business stakeholders what they want to commit to next, that meeting has both a coordination and a transaction cost. By coordination, I mean organizing the meeting, inviting people, scheduling it, getting their commitment to actually attend. And the transaction cost is the cost of holding the meeting. How long does it take? How many people are attending? These things are important. If the transaction and coordination costs are high, then we don't want to hold the meeting too often. If we can make the transaction and coordination costs low, then we could hold these meetings frequently. However, there might be a lower bound to how frequently, and that's bounded by the arrival rate of new information. If our business stakeholders don't know anything new since the last time we held the meeting, they will generally feel their time is being wasted. I saw there was a question there that might be interesting to answer. It says, why ready is always left except for release? I think the simple answer to that is that we're not visualizing on the board the actually released work. That would be, it's already delivered at that point, and therefore perhaps we don't care about visualizing it. There are certainly examples in real life where the recently released tickets are left on the board for some period of time in order to demonstrate what we've done for the customer recently. But generally, we consider that the tickets have left the Kanban system once they've moved to the right-hand side of release ready. The term ready is referring to a buffer. So development ready is the commitment buffer, and it's buffering work that the developers can pull, which have been committed by the business. So developers can pull from the development ready buffer without asking any permission. The test ready buffer in this example may be buffering a particular dynamic with testing. It could be that testing is uses an environment which is only available at certain times of day or certain days of the week. And because of that non-instant availability of our testing environment, we need to buffer up work to be tested in a batch when our test environment becomes available. The release ready buffer is buffering items on the assumption that we're not doing continuous deployment, that in this example, that there's some deployment process or activity which is downstream or only happens at some particular frequency, and we're coming to that on the next slide. So the arrival rate of information affects how often we hold the meeting. If information doesn't arrive frequently for the business stakeholders, they would rather hold the meeting less often and make the size of the buffer bigger. One of the most frequent replenishments I've seen in any Kanban system is actually a TV company in Brazil where they use Kanban for the post-production on the daytime soap opera TV programs. And they're using Kanban to manage the video and graphic editing once they've shot the raw footage with the actors in the studio. That recording, the video recording, happens 11 days in advance of broadcast of the TV shows. So they have 11 days of lead time to make edits and make post-production graphic changes to any of the video frames that are going to be broadcast on the particular TV show. They find that new information arrives very rapidly, that the writers make changes to scripts, they make changes to plot lines. So other things can happen, like the weather changes where they're doing a location shoot and they find that the video shot on a different day doesn't match with other video that has all to be edited and spliced together. And as a result of all this new information, they find they need to replenish their Kanban system twice a day. Of course, that's very rapid. Most software applications I see, it's much more common to do replenishment perhaps once per week. With IT operations, it might be more likely that you do it once per day. But twice per day is still very unusual. So the summary here is that frequent replenishment is more agile. The more often that we can have a discussion with our business stakeholders, the longer they can defer commitment, which means that things remain optional for longer, that we're less exposed to downstream aborting of work that was committed too early, and that the delivery time for work is usually short from the point of commitment to when it's completed. So the business agility goes up because we have a faster replenishment frequency. On-demand replenishment, that if we could replenish every single ticket one at a time, as soon as there's a Kanban free, we hold a replenishment meeting, we replenish the system, that would be the most agile. But that's difficult to achieve unless your business stakeholders are co-located on the same floor of the same building. Very difficult to do unless you have instant access to the business stakeholders. The next thing here is delivery frequency. This is how often do we flush the release ready buffer by deploying to production. And again, this problem has coordination and transaction cost. It has coordination and transaction costs on the service delivery side for the IT workers, but often more important is the transaction and coordination cost on the customer side. What is the impact for them of taking delivery of new working software, and what's their tolerance for taking delivery? What frequency will they be satisfied with? So while we may have a capability to deliver more often, if they're not willing to accept it more often, there's no benefit. So often to improve this delivery frequency, we have to do work with the customers to help them take delivery more often. The result is that the business agility only improves if we work on the outside of the problem, not on the inside. So user acceptance test and release buffer sizes can reduce as the frequency of delivery increases. It's quite common for these buffers to be infinite, simply because from a managerial perspective, we don't care how big they are. There's an assumption that we have an infinite capacity to do user acceptance testing, and that the size of a release doesn't affect too heavily the number of people involved. If user acceptance testing or release was somehow constrained in terms of the number of people or the amount of time that we had available, then we'd want to introduce Kanban limits for these things in order to protect us from overburdening our user acceptance test or release capabilities. But that's a relatively unusual circumstance. It's common for us to see those to be infinite buffers. So the message here is that more frequent deployment is more agile, and on-demand deployment is the most agile. So the faster you can make it, the better. But unless the customer's actually taking delivery and using what you're capable of delivering, then they will not perceive an improvement in the business agility. This is not just a one-sided problem. It's not a technical problem. It's a business problem on the customer side. most of the time. Hopefully, as we go through this, you'll be recognizing that Kanban is a way for managing your business. So to stress this again, it's not a software development methodology or a project management methodology. This is a management approach for managing your business better. And that means that really to do it to the fullest extent, what we refer to as deep Kanban, you need to be involving the customers, and they need to be starting to work with you in a more collaborative way, and ideally embracing the idea that Kanban gives them better service delivery, and therefore it's a good idea for them to get involved and to use it in the way that's intended. Deep Kanban systems are designed from the outside in, based on the customer demand and the customer's business risks. When we see shallow implementations, they've usually been focused only on internal problems and solving the overburdening of the workers doing software development or testing or other service delivery activities. And typically all that results from that is some quality improvements and perhaps a little bit of a reduction in the delivery times. The benefits are not terribly impressive. Once you start designing Kanban systems from the outside in with the customer in mind, then you start to see really significant business benefits. This next point is that you don't need to commit to the delivery at the point when you commit to start something. You could defer communicating a specific delivery until a ticket has moved its way across the board and is closer to the delivery point, and therefore you have a greater certainty about when it will arrive. And we're now, in this example, committing to the release date when the tickets arrive in testing or user acceptance testing. It's not always appropriate, but there are many times when this is an available choice. And the mnemonic for this is that Kanban uses a two-phase commit. Defining the Kanban system lead time, just to put some rigor around how we report metrics. The clock starts ticking when we commit to a ticket. The clock does not start ticking when the customer submitted the idea, because that idea is subject to discard and it's actually only an option. We need to train customers to recognize this and to recognize that we haven't accepted their order until they committed to definitely wanting it. So the clock starts ticking when things enter our input buffer. And from a Kanban system perspective, the lead time stops when we hit the first infinite queue, because as soon as there's an infinite queue, there's no longer a Kanban system. This produces the right result for an equation from queuing theory called Little's Law. And what you have here is the algebra for Little's Law, that the average delivery rate equals the work in progress divided by the average system lead time. And below we have a cumulative flow diagram which shows the geometry of the problem. This cumulative flow diagram is showing a backlog of ideas. It's showing when we started working on them, and it's ultimately showing where we complete the work and things are ready for deployment. The height between started and finished is the quantity of work in progress. The horizontal distance between started and finished is the average lead time for items started on the day indicated on the left-hand side with the pink arrow. And therefore, the slope between those 2 points is our average delivery rate. This equation becomes very useful for medium to long-term forecasting. So anything over a time period of 3 months or greater, typically Little's Law is a very useful equation for us to understand the delivery rate and how long it will take us to complete a batch of work. So the customer lead time, of course, the clock will start ticking at the same point when we commit to something, but customer lead time will include downstream batch transfers, such as the user acceptance testing and the delivery, the deployment in this example. And you'll see in this slide that we do actually have the done column, the deployed to production column for the person who asked a question about the ready. So we need to understand the frequency of these batch transfers if we're able to calculate and promise a lead time to the customer. The next thing for us to consider is known as flow efficiency, which is the ratio of time we spend working on something compared to the time that it took us to deliver it to the customer. So flow efficiency is this equation. It's the work time divided by the lead time times 100%. And you will see on this workflow that I've indicated particular columns are definitely waiting columns. And then there are columns where we're performing activities like development, system test, user acceptance test. But I haven't colored those all green because often we are multitasking with these activities and tickets are not being worked on constantly. So the working time is usually a smaller fraction of the time that the ticket will spend in that column. So I've indicated that by using the gradiated color scheme from green to red. So the question is, what would you think a reasonable flow efficiency would be? Well, in a manufacturing plant, they will achieve perhaps 90% or greater flow efficiency. What about with knowledge work? Well, a number of people in our community have started to report this data, and some examples recently here are shown in these references. Zoltfa Bock is from Budapest in Hungary, and Håkan Fors is from Stockholm. Håkan is a consultant and he works with clients around Sweden. And between them, they've reported numbers of 1 to 5% are typical. My personal experience is 5 to 10%, 5 to 15%. The team at Microsoft in 2004, the very first Kanban, they had 8% flow efficiency. Greater than 40% is a good number. If you spend time improving your organization, you might get into the range of 40 to 60% flow efficiency. Now, why this is important is to recognize where our sensitivity is for improving. If I flick back briefly to our Little's Law equation, you'll see from this that the system lead time directly affects our delivery rate. So imagine that we're 5% flow efficient. Let's leave the picture like this. We're 5% flow efficient. It takes us 5 days to do development testing and user acceptance testing, but it takes us 100 days from commitment to delivery to the customer. So where is the big leverage for improving the delivery rate to our customers? The leverage is actually in reducing the waiting time to understand the sources of delay and directly attack sources of delay in order to reduce them. And that drives down the lead time, and as a result, for a fixed quantity of work in progress, it drives up the delivery rate. It makes us faster from commitment to delivery, and it makes us faster to deliver batches of work because the delivery rate increases. This is also an indication that individual workers or the way of working is not a significant leverage on improving lead time. If we're 5% flow efficient and half that time, half the working time is development, given our example, we'd have 2.5 days of software development in a 100-day lead time. If we improve software development by 10 times, we make it 10 times faster, we would shrink the 2.5 days to a quarter of a day. The net effect is that our lead time would shrink from 100 days to 97.75 days. The delivery rate improves by 2%. If you're in a low flow efficiency world, improving developer productivity is a low leverage activity. That a 10 times improvement in software development will result in a 2% improvement in customer delivery. So the customer will perceive that nothing has changed. You might perceive that a lot has changed, the customer won't care. In a low flow efficiency world, the way of building the software and the capabilities of the individual engineers is not sensitive to the performance of the whole system, or the performance of the system is not sensitive to the engineering capability. If you were in a high flow efficiency world, then that would be different. The individual engineers would affect the lead time performance significantly. The way of working would affect lead time significantly. So understanding flow efficiency is absolutely critical for us to know which problem we're solving and where the high leverage is in improving our organization. This next slide shows us a histogram of lead times. And on the x-axis, we have the lead time ranging from 1 day to 160 days. And the y-axis, we have the number of tickets completed in a given day. And if we know this information, we can start to understand the average time to deliver a ticket. And shown here is the 85th percentile, which is the first confidence interval above the mean, and the 98th percentile. So if a customer came and said, how long does it take you to complete a change request through this software maintenance department, we would say on average 31 days, and 6 out of 7 items are completed in 44 days or less. So this gives us a probabilistic understanding based on recent history. Actually, this data is what's called multimodal, and that turns out to be true because we have two different types of work. We have production defect fixes and we have change requests. If we were to filter those out, we end up with two pictures like this. These are distribution curves for the single modal data for the two separate types. And you'll see now that we have a much richer understanding. We fix bugs on an average of 5 days, and they can take up to 25 days. On the other hand, change requests, they take us an average of 50 days. We get 6 out of 7 completed within 60 days, but it can take up to 150 days or more in order to complete a change request. So this is useful information. If someone comes along with a bug fix, we can tell them 6 out of 7 bugs are fixed within 2 weeks. That's a significantly different piece of information than we had on the previous slide, which would suggest that the average was only 31 days or 6 weeks. So this Kanban board is now separating out the two different work types using two different rows on the board, and we're actually introducing Kanban on these horizontal lanes in order to allocate the capacity in the system across the two different types. And if we do something like this, this helps us improve the consistency of the expected lead time distribution. And as a result, we can expect these lead time distribution shapes to remain fairly constant as long as we're not doing process improvements. That means that we can use this, the lead time histogram and the best fit distribution curve based on the real data. We can use that for communicating expectations to our customer. So there's a question about which instruments can be used to improve flow efficiency. So no, I'm not going to address it in the rest of the presentation, so I'll take it briefly now. The whole point is that flow efficiency is about eliminating delay. So you need to identify sources of delay. The most obvious source in a pre-Kanban environment is too much work in progress, too much work queuing. So introducing Kanban limits and reducing the size of queues will significantly improve flow efficiency. In addition to that, we want to look at blocking issues, why items become blocked, and see if we can do root cause analysis on those, and perhaps some risk management where we look at risk reduction or mitigation on the blocking issues, or ultimately a root cause analysis and elimination where the reason for something blocking is removed from the system completely. Those are the main ways, but there may be other reasons why things delay. But the point is that you must focus on reducing sources of delay. So infinite queues decouple systems. You see the infinite queue on deployment ready here. That's indicating that one Kanban system is separated from our deployment activity, or there could be a downstream process for doing deployment, perhaps performed by different people. So we think of our software development here as a service, and then the downstream, there's a second service for doing deployment. That could have a Kanban system, but we don't know. From this visualization, we're not capable of determining how deployment is done. We've talked a little bit about buffers already in the presentation. The word ready is usually an indication that we have a buffer. And buffers are there usually to buffer non-instant availability or batch transfers with some sort of cyclical cadence. There is another circumstance where you would use a buffer, which is where you've identified a definite bottleneck in your process, a capacity-constrained resource. But relatively speaking, those are quite rare in our software development world. Rare because there's so much variation in the nature of work from one ticket to the next. Identifying a consistent bottleneck is actually quite difficult. But for a complete list, we would expect to see buffers for non-instant availability problems, cyclical batch transfers, and bottlenecks. So the buffers here, the engineering ready, that's buffering the cadence of the replenishment. The deployment ready is buffering perhaps the availability of the people who do the deployment. It's important to realize that the done column here in development is not a buffer. It might be a separate queue, but all it's really doing is signaling that tickets are completed in development and available to be pulled. So it's a pull signal mechanism. It's an availability signal rather than a buffer. And that's an important distinction, that you use buffers where you need them, but things like the done subcolumn here, you will always need that. You'll always need it because you can't prevent something from being completed. And once it's completed, it's nice to know that it's available to be pulled to the next stage. If we can do all these things, we can start to get smart about what we should commit to and when. And there's a concept of the optimal time to start. So this pair of axes here, the y-axis shows the impact, the benefit to be derived from deploying a piece of software. The x-axis shows time. And many things are somewhat seasonal in nature. If we're deploying software, perhaps to help with marketing in a company, and we have a promotion for Easter, then we would want to deploy that in early January perhaps, or perhaps with Orthodox Easter it might be later into February. But we understand the concept that we'd like our Easter-related functionality to be on our website in February and March and into April. So there's a question here that says, is it correct that ready buffer requires prioritization commitment meeting while done is an automatic signal for somebody to grab it for the next phase right away? Yes, that's correct. So the S-curve on here is showing the potential benefit of something that's being deployed for a seasonal purpose like an Easter promotion. And if we had that code ready in November, there would be no additional benefit. We can't deploy the Easter promotion web pages in November. We need to hold them back. So ideally, we'd like them to arrive just in time for when we need them. So how would we go about determining that? How would we go about understanding when to commit to an item intended for promoting Easter? When would it get pulled onto our Kanban board? Well, if we know when we need it for, we can use our lead time distribution, and we can pick something like the 85th percentile, and we can back out from there. And this gives us the ideal starting point. If we start here, we have a 6 out of 7 chance of delivering the item on time. And if we deliver a little late, well, we lose some opportunity. And not included in these slides, I have risk management slides for understanding the sensitivity to delay beyond the ideal point. If we look at this lead time distribution here, and if you remember the numbers, the 85th percentile was 60 days. The 98th percentile was 150 days. In order to guarantee delivery without doing anything special, we would need to start this item 150 days in advance, more than twice as much as if we're willing to accept a 6 out of 7 chance of delivery on time. So having this level of understanding really helps us to perfect our risk management and understand the balance that we're striking when we choose to commit to something and get started with the intention of delivery. So to summarize metrics for Kanban systems, we're interested in cumulative flow diagrams. They're very useful because they integrate the demand, the quantity of work in progress, the approximate average lead time, and the delivery rate. And that's a lot of information on a single picture. We also really love lead time histograms. They show us the actual lead time capability. They allow us to develop best fit distribution curves, and we use those extensively in risk management and planning and forecasting. We also care about flow efficiency because it tells us which problem we're trying to solve and where our leverage is for significant improvement. And there are some other things that we might use that I don't have time for in tonight's presentation. Separating out value versus failure demand, looking at the initial quality, the number of bugs we're generating per ticket delivered, the impact of blocking issues, the ability for us to harvest the blocking issue tickets, understand how many days of delay were incurred, doing some root cause analysis, and then prioritizing sources of delay for risk management, reduction, mitigation, elimination. These are all very useful, but the primary metrics are our cumulative flow diagram and the lead time histogram. So a note on implementing a virtual Kanban system: do not copy an existing Kanban system. Do not copy any of my examples or any other examples you find on the internet. Each system has to be designed from first principles using what we call the system thinking approach to implementing Kanban. You need to study your service delivery and your workflow from the outside in. Look at the demand, including the business risks. Look at your current capability. You gather metrics to understand your current capability. And given all the types of work that you service and all the ways that you service them in terms of priority, or we use the term class of service, usually related to specific business risks, you take all of that together and you design your visualization and your virtual Kanban system around your existing workflow. So it really has to be done from first principles to work properly, and it has to be done from the outside in order to be a really deep Kanban implementation that helps improve the business agility. So to hit on this point again, the Kanban method is not a project management or software development lifecycle process. And I'm really trying to discourage a process-centric approach to improvement. What we have here is a management method intended to help you run your business better and to recognize that all workers, regardless of their pay grade, they have some level of management authority because they're making decisions that affect the performance of your business. So recognize that management isn't just a task for managers. Managers with higher pay grades simply have authority to make more important decisions about more significant risks. And if we can make the policy explicit around which pay grades have which levels of authority, then we can make it much more clear how empowered the organization is and where management authority lies, and recognize that some management authority always lies with even the lowest level knowledge workers. And finally, the point here that you must Kanbanize your existing workflows, your existing service delivery workflows. Don't look to install some process definition. There's a question about, do you have some efficient approaches for accumulating the info for the charts? I don't know whether I should type the reply or just say it, but do you mean using physical boards? Because if you were using software for doing the Kanban, then you would expect the software to produce the charts for you. So the answer is yes. Well, there isn't a great deal of information there if you think about it, or at least it's not difficult. If you're building a lead time histogram, all you need is to write the start date on a ticket when it enters the ready input buffer, and you need to write the end date when it moves across the board to the done column. So you just write the dates on the ticket, and you harvest the tickets perhaps once a week, and you put those dates into a spreadsheet, and that will very quickly enable you to produce the histogram. There's a suggestion that maybe you could take a photo of the board. Well, that will certainly help. Understanding the quantity of work in progress on any given day is just a matter of counting tickets. So producing a cumulative flow diagram is not particularly onerous, even on a daily basis, for a reasonable size of Kanban board. There is, in fact, a software product on the market which enables you to print tickets with QR codes. It's open source software from Jimdo in Hamburg in Germany. And that uses a digital camera to take photographs of your boards automatically, and then it translates the photographs into Jira and generates the metrics for you. It's quite a practical hybrid solution, and Jimdo developed it for their own internal use, but they're not a product company in that sense. They're not interested in making management tools, so they open source the software. But to be honest, generating metrics off a physical board, the useful metrics that we care about, is not an onerous activity. It's quite straightforward to capture the lead time, which is very powerful. Capturing the arrival rate of incoming tickets, it's not obvious how you would do that because it depends how does your customer submit an incoming ticket. But capturing tickets that are on the board, not difficult. As you suggest, take a photograph, just count them, and then maintain a cumulative total in a spreadsheet and ask the spreadsheet to print the area graph for you. The next question is, can I recommend Kanban software? There are only 2 products on the market that I recommend for enterprise scale use. There's LeanKit and Swift Kanban from a company called Digite. LeanKit, the company's called LeanKit, and the software is called LeanKit. There are some other software which are useful for smaller scale applications or for single services or for simpler service delivery. So if you were simply doing software maintenance or perhaps some IT operations, you might find the Kanbanary software from Lunar Logic in Krakow to be quite good. I also understand the latest version of Target Process from from Target Process in Minsk in Belarus is featuring a lot of new Kanban functionality, but I haven't seen it yet. The question is, what about Jira? And of course, Atlassian have their Jira Agile, which used to be known as Greenhopper. That's really a significantly deficient Kanban software. If you're using Jira as your system of record, it would be a much better idea to use Swift Kanban or LeanKit running on top of Jira. Use Jira as the system of record, but use Swift Kanban as the system interface. Particularly if you're doing a large project development, the only 2 systems on the market that can do hierarchical requirements are LeanKit and Swift. So I don't recommend the Jira Agile. The Atlassian are not sufficiently committed to the Kanban market at this time. If you're using Jira as the system of record, get a proper Kanban tool. To be honest, you're trying to run your business better here, right? Don't skimp on the tools. Spend money and do it properly. The benefits to be gained from doing Kanban properly are measured in hundreds of percentage points of productivity improvement. If you can turn a 5% flow efficient organization into a 50% flow efficient organization, you just improved the delivery rate by 10 times. What's that worth to your business? Why wouldn't you spend money on the tooling? Right? Cheap tools will restrict your ability to improve your business. So, getting back to this. The next thing here is a collection of feedback loops. Remember the 6 practices at the beginning, one of them was implement feedback loops. These feedback mechanisms are known collectively as the Kanban kata. And there's 3 of them: the stand-up meeting, the service delivery review, and the operations review. And just briefly show these. So the stand-up meeting in front of the Kanban board, and there are 2 versions of the kata, whether it's a lower maturity or a higher maturity team or organization. And we're looking at a disciplined walk through the board, and in this case, the provoking acts of leadership from people involved in the service delivery, and those lead to service improvement opportunities. And what we're expecting is that the improvement opportunities get discussed at meetings after the stand-up meeting. But the stand-up meeting, everyone in front of the board, they're seeing what's going on. It's the basic level of feedback, and we expect that to happen daily. A service delivery review is typically a relationship between a service delivery manager or some form of function manager, line manager, or second line manager, director perhaps, where on a weekly basis we're looking at the objective metrics for demand, capability to supply. We're comparing those. We're looking at the customer tolerance, that the target conditions for things like lead times, if we have a service level agreement perhaps, or an expected delivery rate. And if we're not achieving those, then we might talk about where there's an opportunity for improvement. There's a question coming in that I think still related to software, or maybe it's a general question. It says, is it possible to use Kanban in distributed teams? Yes, it is. In fact, it's always been a distributed team activity because it's not a team level thing, right? It's really, really important for you guys out there who are doing Agile and doing Scrum that you get it out of your head that Kanban is a team level activity. Even from the very beginning, the first ever Kanban that we implemented at Microsoft in 2004, it was a multi-department workflow spanning different activities like development and testing in different departments and user acceptance testing and deployment. And the development and test group was in Hyderabad in India. The customers and the people doing user acceptance testing and deployment were in Microsoft's office in Seattle in the United States. Kanban has always been a distributed thing for me, and it's never been a team thing. This is an end-to-end workflow service delivery method. So the next question is, does Kanban require estimation of tasks before putting on the board ready for the dev column? No, it does not. Do I need to elaborate? What is it you didn't understand about the lead time distribution? Service delivery reviews, the idea is they happen weekly. They're objective, quantitative, they're metrics driven. And what we're trying to understand is whether our system is delivering what's expected of it based on customer expectation, customer tolerances, and talking about what we might do to improve it if we're not hitting the expectations. There's another question about how would you define the maximum number of items in a column. So defining the work in progress limits is a bit of a black art, that you can have very simple policies like 1 item per person or 2 items per person. You might say we'd prefer to have 1 item per person, but we know that there's quite a lot of items get blocked. So we'll allow 1 per person plus 3 blocking tickets. If we have 5 people working in that particular activity column, then the number would be 8. So that's the based on working practices approach. There's another simpler approach that with most of the Kanban boards I've seen around the world over the last 5 years, if it's a proper end-to-end workflow Kanban designed from the inside out, it's quite unusual to see individual columns that have numbers greater than 10. and the lower limit is usually 2 or 3. So if the bounds of a typical individual column on the board, the upper limit being 10, the lower limit being 3, then why wouldn't you start with 5 or 6? So I'll often say to people, if you don't know what number to start with 5. Put 5 across every column on the board, 5, 5, 5, 5, 5, 5, the whole way across the board, and then adjust up and down as you see fit as you get started over the next few days or weeks. There's another approach that said, why wouldn't you just start with what you've got now, count the current work in progress, set that as your WIP limits, and then gradually reduce them? No, not 5 times the number of people, 5. There are a few companies I've met where that would be too small of a number, but very few. One of them is a Scandinavian telephone equipment manufacturer, and they have departments with perhaps 30 people, and they had boards with up to 300 tickets on them. So if you have 6 programmers, then maybe start with 6, yeah. On the other hand, that might be too aggressive. Maybe start with 9 or 10. Good opportunity to have pair programming, but if that's not what you're currently doing, if you're already pair programming, then you could start with 3. But that might also be too aggressive. So start with 3 plus 2 blockers. So the number would be 5. And we're back at 5 again. Knowing how to pick the numbers in the first place is really a coaching level skill, because the tolerance in your organization for limiting work in progress is heavily related to the organizational maturity. So more mature organizations are capable of having much stricter limits, where more chaotic, immature organizations probably need a much larger limit, and they gradually reduce that. Obviously, it will take longer to get the benefits and results if that's what happens. I thought there might have been another question in there somewhere. It said, can you elaborate on the trade-off between lead time for feature and production and throughput? The most often one releases the more overhead. Yeah, so the idea that there is a transaction cost to making a deployment, is that what you're asking? Right, so the answer is yes. And yeah, if you have a transaction cost to making deployment, you need to buffer that. And what your Kanban system will do is it will demonstrate the cost and impact of that deployment, that the buffer, or sorry, the batch size on the deployment, the delay for the deployments. And it will focus attention on the business impact of batching deployments, because there's a cost to doing it. And the opportunity, of course, is to focus on reducing the cost of doing the deployment, or perhaps, I think more commonly, of the customer taking delivery. I know that a lot of your clients are financial sector clients like banks. And my observation is that banking systems, if it's perhaps a system used in their branch banking, the cost of taking delivery in the branches and training the workers to use the new software is far more significant than the cost of doing the deployment. Therefore, providing the customer with the data to demonstrate that lead times are longer because of their inability to take delivery more often, and that with longer lead times, you're less agile, that you have to commit earlier, that there's probably more related waste, there's more aborted items, there are more rework because of changing requirements, There may have to be bigger WIP limits because of changing priorities. There are many consequences of longer lead time. So Kanban isn't telling you what to do. In fact, it's largely agnostic to whether you do continuous deployment or whether you do large batch deployments every 6 months. The Kanban system will just show you what's going on. It's like a mirror to the current process. So I know I have not finished the presentation is the question. In fact, I still have quite a lot of the presentation to go. So operations review, to get back to the presentation, operations review is a monthly meeting and it's designed for the system of systems. So you might do this at the business unit level where you have multiple Kanban systems all reporting their service delivery review material to each other so that you can observe the interdependencies between different services and how they impact each other. And this provides us with a larger scale ability to make adjustments. And we expect operations review meetings to be held monthly. So to summarize the 6 practices and to be much more explicit and prescriptive here, we expect that to be doing Kanban or using the Kanban methods as a way of managing your business, you're visualizing work, workflow, and business risks. You're implementing virtual Kanban systems. You're managing the flow. You're making process policies explicit. Those are the same as before. You're implementing the 3 Kanban kata. And you're educating your workforce to enable collaborative evolution of policies and ways of working. And educating them with models like the theory of constraints, Deming's theory of profound knowledge, lean, risk management ideas such as real option theory and liquidity, and using those models to help interpret what's going on and therefore making intelligent decisions about where to make improvements and what you would expect from a specific change. A few slides on scaling out. So this picture intended to show 3 different Kanban systems within a single business unit. And they're all different. Each one is unique and different. They have different sources of demand. Some of them service one customer, some service several. And they actually have interdependent demand. So one system is asking the other one to do stuff for it. Perhaps the one in the top left is an application team, and the one in the middle is a platform, a development organization, and the one in the bottom is a shared service like architecture or database administration. So we have a network of interdependencies, and in order for this whole system to improve, we need to be able to balance the demand and capability amongst the 3 different interdependent systems. And the way that's done is by using our service delivery review and our operations review mechanisms. That the outcome, the overall capability of this system of systems is emergent. It emerges through the interaction of the feedback loops. So right back at the beginning of the presentation, I talked about Kanban as a 2nd generation Agile method, where it's a method for making your organization adaptive. It's not just about adapting to changing requirements. And this is how it's done, that we scale out Kanban as a service-oriented architecture where you look for services in your organization and you implement a Kanban system for each one. And then you allow them to modify themselves by using the service delivery review and operations review meetings as the feedback mechanism that tells you where to make adjustments and improvements. And that's what this slide says, so I'll skip over it. So to summarize the benefits, Kanban gives you a shared language for improved collaboration a shared language between you and the business side. That you start using the same language for the work item types that are being requested, the business risks associated with those types, and we start making all of that transparent. That you get a shared understanding of the dynamics of flow, and that people are engaged emotionally through the visualization and the tactile nature of physical boards. And that there's greater empowerment without loss of control, because we can make management policies very explicit, and we can make it explicit which person at which pay grade has the authority to override a policy temporarily or to change a policy. And the policies provide very clear boundaries for what people are allowed to do within their own scope of authority. There are tangible business benefits, improved predictability of lead time and delivery rate. That primarily comes from the fact that you've got a Kanban system limiting the work in progress. You'll see reduced rework because quality goes up, because people are not overburdened and they're much more focused. You can also enforce really quite strict quality control through things like exit criteria or definition of done, by implying what does it mean to be done to signal that something's pullable. If it's in that done column or it has a green magnet on it to show it's pullable, what had to be true before that was allowed? And you can control those policies very strictly with Kanban. Improved risk management, improved agility, not just of the software development, but the whole business, and improved governance because everything is so transparent. There are organizational benefits, improved levels of trust and organizational social capital, improved organizational maturity, better decision making, better risk management. Nobody panics when something goes wrong. The emergence of system thinking as an organizational skill. Management focused on system capability through policy definition, and also focused on where's the leverage point for improvement. That all too often I see software development organizations, when things are not going well enough, they try to make the software developers work harder, or they get rid of those developers and they get other ones. Perhaps they move work from one office to another, or they outsource it to a different company. And often that doesn't produce the improvement because they didn't know which problem they were solving. And then organizational adaptability, that if we're capable of understanding the system from the outside in, understanding the demand, the type of demand, the arrival rate of demand, the business risks associated with that demand, then we can study that from month to month, and we can adjust and adapt our service delivery capability in response to changing demand. It makes us resilient to a changing external environment. There are change management benefits, significantly reduced resistance to change. You start with what you do now. Nobody's job title changes. And you figure out where your number one problem is and you start working on it. And hopefully you're doing that in a collaborative, consensus-driven way. So resistance to change of adopting these prescriptive methods, that evaporates. Processes are uniquely tailored to your business environment and the risks under management. There's no such thing as a defined Kanban process. Evolutionary changes reduce impact during the change, and lower the risk of failure. A tremendous number of change initiatives in companies fail. And with Kanban, you're doing lots of little experiments frequently. And while you expect lots of those little experiments to fail, the big picture is that you're always improving. And lastly here, Kanban's designed to be change led from the middle. It's not a bottom-up initiative. It's not a team level or individual contributor initiative generally. And yet it doesn't need senior executive authority. You don't need to create a change initiative with a big program and a big budget to do it. You just teach middle managers to manage differently and you get started. Generally, people who take Kanban training can implement what they learned the following Monday without asking a lot of permission or spending a lot of money. And the result of that is there's a reduced need for coaching and process specialists in comparison with Agile software development adoption, or for that matter, more traditional software development process adoption. So I think this might be the last slide here. Kanban improves your business agility. Lead times gradually reduce. Predictability against expected SLAs or forecasts for larger projects, that improves. Organizational capital improves. Governance and risk management are improved. You get empowerment without loss of control, and the improvements can be dramatic. There's a documented case study published in the IEEE management from the BBC where one department increased their delivery rate by 700%. Their on-time delivery improved to greater than 90%. And delivery times were reduced by up to 90%. That reduction in delivery time allowed them to deploy web pages to the BBC's website faster, and those web pages serve advertising. They increased, or the earlier delivery increased the ad impression rate to generate an extra 600,000 British pounds, or about $1 million US, from a department of 30 people over a one-year period. So they got a $30,000 US per person improvement from this. So it's a very measurable business benefit. We're talking about something in the region of 1/2 to 1/3 of the salaries of the individuals were recouped through faster delivery of web pages on their website. Or put another way, the cost of running that department fell by almost half. That's a really significant business benefit. There's a couple of slides on learning more, some references to books and websites. And that's the presentation over. We still have a few more minutes for some more questions. Let me see what we have here. So there was a question about specific issues of process gates and change management gates that in fact cause a lot of batching. Yes, they do. And your Kanban will expose that and help you expose the cost of it. So if you have process gates with a lot of batching, your flow efficiency will be very low. Therefore, reporting the flow efficiency and identifying the sources of delay and perhaps quantifying each source. So if flow efficiency is low, lead times are long, you might start to report the amount of time that things spend queuing for those process gates, and then engage the customer in a discussion about the cost of delay. That if you could remove some of that delay, they would get faster delivery. They'd get, so both the lead time would shrink and the delivery rate would rise, and discuss to them what's that worth economically, and do they feel they're making a good risk trade-off between their process gates, which are generally there for a combination of risk management and governance reasons, versus the economics of their business. And now that's a discussion you can have with quite a senior manager. You can front it up to them as a choice, we're currently very slow. This causes an impact in terms of delay that has an economic value for your business. And you're currently choosing that because you want to have these governance and risk management policies in place. Do you recognize the cost of these governance and risk management policies, and is that acceptable to you? And if not, would you consider changing? Would you consider relaxing the governance policies or attending the phase gate meetings more frequently in order to reduce the batch size, in order to reduce the delays and improve the flow efficiency, and provide the customer with a set of choices so that you're now creating a decision framework for the customer to understand the impact of their own choices. There's never a right or a wrong with Kanban. There is just a set of choices with consequences. And often customers do not understand the consequences of the choices they've made, or risk management and governance decisions are made out of context from the business objectives and the economics of the business. You'll often find in big banks, for example, that the people in charge of the governance processes are completely separate from the business people doing the banking. Therefore, in their opinion, more governance is better. And the more governance you can have, the better it is, because all they want to do is reduce risk. But if they're reducing risk at the expense of damaging their business and their business's ability to perform well economically, then that's not a good decision. And you can produce the metrics that you can put in front of the right level of manager to engage them with the decision-making and framework. And hopefully some change happens. And that's about as good as you can hope for with Kanban, that it gives you the evidence to have the right discussions. There's another question here. It says, how do you manage hierarchy of prioritization? Sometimes it's only feasible to prioritize on a high level, then it needs to be translated to low-level features. So I didn't show in the presentation, but it's perfectly reasonable to build hierarchical Kanban boards. With physical boards, 2 levels of hierarchy is feasible. With software tools, you can have more than that. You can have 3, 4 levels quite easily. The Swift Kanban and LeanKit Kanban products both do that. So that creates a parent-child type of dependency, and that, of course, is a form of batching. It's a perfectly solvable problem with Kanban. The tickets on a Kanban board don't need to be independent. You just need to find ways of visualizing the dependencies. Parent-child dependency is quite easy. Typically, you use columns for the parents to move across, and you use rows on the board for the children. So if you have a high-level requirement and then something lower level, like a user story, the user stories will flow through the rows, and the high-level requirements will flow through the columns, effectively a 2-tiered Kanban board. Can you use estimations of delivery rate of high-level features? Yes, you can. Of course, with high-level features, you won't have as many data points, and it will depend on the frequency of the arrival rate of them to determine how accurate. Some very simple linear regression using something like Little's Law, that becomes effective over medium-term time horizons. If you're not doing linear regression, if you want something more accurate, then you can do things like Monte Carlo simulation. Monte Carlo simulation built into both the LeanKit and the Swift Kanban products. You have to pay extra for it. It's quite expensive, but not everyone in the company needs to have the Monte Carlo simulation capability. There are some other things that we teach in our classes that I don't have time to get into, but linear regression is a reasonable tool over medium-term. Short-term time horizon, you need to look at other solutions. The simplest solution and the most common is to use class of service. That if someone looks at the standard lead time distribution and said, wow, 85% in 60 days, but 98% in 150 days, I don't want to take the risk of being in that, upper 15%, then you might say to them, why not? You might say, what risk are you trying to avoid? And if the risk is sufficiently important, we'll give the item a higher class of service, and we'll guarantee that it's completed in less than 60 days. And that's a perfectly reasonable thing to do. You're giving an item of high risk a higher class of service, and therefore a different queuing discipline, a different priority as it's pulled across the board. That's appropriate if the risk is genuine. If the risk is not genuine, then it's not appropriate, and it should just go in the queue with everything else. How do you determine which task to pull from the ideas? If you don't have an estimate for development effort for different tasks which have similar value? Well, first of all, I dispute that you actually understand how to calculate the value for most IT work, and certainly for things like applications being deployed in banks. You can't determine the business value for individual features. You have no idea what the monetary value of those things is. On the other hand, you can almost certainly qualitatively assess the business risks associated with different items. And I teach an entire 2-day class on that topic, on how to understand business risks and how to facilitate the sequencing and selection and commitment of tickets. That's my risk management masterclass. And some of that material is included at more of a surface level in our advanced practitioner level class called Practicing Kanban at Scale. It's typically material that I can't easily get into in a presentation like tonight, but there are videos of me presenting some of that material from Lean Kanban conferences. The more recent ones would be the Lean Kanban North America in Chicago last year, and the Stop Starting, Start Finishing conference in Stockholm in March of last year. But there are also some older ones, but the more recent ones obviously have the newer material. Next question is, what event moves an item from dev done to test ready column? Just the Kanban signal. And remember that test ready in my examples is there because there must have been a real world situation that required a buffer, something like non-instant availability of a test environment. If that problem didn't exist, there wouldn't be a test ready column. That inserting a buffer like test ready is a specific thing that you only do if you know why you're doing it. Next question is, but if some features takes only 1 hour of work and others take 50 hours, sometimes it's useful to do 10 small features and just one big one. You're confusing level of effort with lead time, and this question would really only be relevant if you know that you've got a high flow efficiency environment. That in low flow efficiency environments, even an order of magnitude of difference in level of effort will not make that big of a difference to the lead time. But generally, if something is as different as a 1 hour of work to 50 hours of work, you would identify that as two different types of work, that it would be obvious that something is a very short activity versus very big. The issue is where they're roughly of the same size and within the same order of magnitude from a level of effort perspective. And generally speaking, that isn't, from a business risk and economic outcome, there is very little leverage in understanding that difference. It's much more important to understand the business risks and to pick items based on their business risk and the benefit that's achieved from delivering them. What's the minimum and maximum possible sizes of the team to use Kanban? If you're talking about a single Kanban board, therefore a single Kanban system, I have seen up to 75 and 80 people using a single board. I've heard of boards with around 100 people using them. That typically something in the order of 20 to 30 people to 50 to 75 is quite common. So we're talking about, if you're thinking of Scrum teams, we're talking about significant numbers of Scrum teams all sharing the same board. I believe we're out of time, so we have to stop there.